our periodic table here. Okay, how many elements are there in the first period? There are 2 elements in the first period, hydrogen and helium. Okay? How many elements are there in the second period? The second period has 8 elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so there are 8. How many in the third period? 8. Okay, the same number right here. Okay, how many in the fourth period? 18. How many in the fifth period? 18. How many in the actual sixth period? Now the sixth and seventh periods are a little bit different because not only do we start here, then we jump all the way down to these guys. All of these elements right here fit in this little area. And the way they fit is, imagine that you had a bendy ruler, okay? A ruler that you could actually bend. And imagine that you actually took that ruler and you actually, each one of those elements was a spot on that ruler. Okay, so all of my lanthanides are here, one after the other, and the beginning of the ruler starts at 57, and we bend it, and I won't do it with this one because it'll break. But imagine this, all of my elements are here, and they all fit into this small little space. Okay, don't ask me why. I didn't make the periodic table. I could probably find out for you, but I've never actually thought of looking it up. All right, so how many do we have in period 6? There are 32 elements in period 6. How many are in period 7? 32. Also 32. Now, these numbers are very, very important because in addition to being the amount of elements that there are in each period, they also help decide how many electrons go on each orbit. So we remember that we've got the same number of electrons as we do protons in any one atom. So in the case of magnesium, I look up to that little number that I've circled in the top corner of the box there, for my atomic number, which tells me the number of protons. I have 12 protons. Therefore, I must also have 12 electrons. And the way that this works in terms of the number of electrons that go on each orbit has everything to do with the number of elements on each period. So in that first orbit, we can only have a maximum of 2 electrons. In the second, and if your element happens to have more than 2 electrons, then you move to the next further out orbit or energy shell. That means that there's going to be a max of 8 electrons on that next shell. Okay? So 1, 2, 3, 4, 5, 6, 7, 8. So what's my total of electrons so far? 10. I've got 10 electrons so far. I've got 2 here and I've got 8 here. What is my atomic number? 12. So how many electrons do I need to put on that third last shell? 2. I need to add 2 more, 1 and 1. So now if I look at this element, I've got as many protons here as I do electrons. Okay, it balances out and it's supposed to. But look at these numbers, 2, 8. I would have a maximum of 8 on the next one. I would have a maximum of 18 on the next one, a maximum of 18 on the one after that, a maximum of 32, and then finally another maximum of 32. So if ever you're unsure of how many electron shells you're supposed to have in an atom. Who knows? You may have to draw an atom. If you're unsure as to how many electron shells are supposed to be there, find your atom on the periodic table. Figure out what period your atom is in. Okay? That tells you how many rings you need. And then fill up each of those rings with the maximum number of electrons that can go in each of those rings. And in the case of what the max is, look at how many elements you have. Okay, you've got a max of 2 elements in the first period. You've got a max of 8 in the second one, 8 in the third. And then you got 18 going across here and 18. Then you've got your 32 all the way back, and then your final 32. So your periodic table can help you understand how to actually draw an atom if you know how to read it. All the information is there. Now, the last little particle that makes up an atom that we haven't talked about is a super important little particle. And it was one of the last particles to actually be discovered in terms of the atom, okay? And here's the cool thing. Have you ever played with magnets?
Yes.
When you try to push magnets together, they do one of two things. They either stick or attract together, or what's the word? Explain it. They reject one another or they repel from one another, okay? Now, the reason they do that is because like charges, similar charges, they can't stand to be next to one another. They repel one another, okay? And look at the nucleus. The nucleus has a whole lot of positive protons in it. If it weren't for these little other particles, okay, the actual nuclei of these atoms would not be stable. The protons would not want to stay together in the nucleus. So the fact that this actually does happen and they stay together means there has to be something else in the nucleus that helps hold them together. And that something is the last of the 3 particles, and that is neutrons. Okay, neutrons, and I'm actually going to make this a little darker so you can see. Neutrons do not have an actual charge. Protons are positive, electrons are negative, neutrons are neutral. And their job is to act like glue. Okay? They hold all the protons in the atom together. Okay, they make the proton stable. They make all the protons in the nucleus stable so the atom doesn't fall apart. That's a really important job. And later on, okay, we're going to learn how to count the number of protons, electrons, and neutrons in any one atom. Okay, but for today, I really wanted to get through what the model of an atom is supposed to look like. So now, if you have an atom that has more than the 12 protons and electrons that we talked about, okay, because we have something all the way up to atomic number 30. Now you know exactly how many orbits you're going to need to make and how many electrons are going to need to go on each of those orbits. You also know how many protons and how many neutrons you will have to put in your actual atom. Because in order to calculate the number of neutrons, if I look at magnesium here, magnesium, in order to calculate your number of neutrons, you look at the other number in the box. And it's always a decimal. And that decimal represents the atomic mass. And that mass is the mass of the nucleus. It is the mass of all of the protons and electrons. So in the case of magnesium, my atomic mass is 24.305. Okay? It has a mass, this nucleus, which is, let's be honest, the nucleus of an atom accounts for 99.99999 infinity of the mass of a whole atom. Okay? Electrons are teeny tiny in comparison. All right? So this is a very good reflection of the overall mass of an atom. If I want to find out how many neutrons I have, I take my mass, which in this case is 24.305, and I round it to the closest full number. In this case, is 0.305 closer to 24, or is it closer to 25? We're going to round down here because it's closer to 24 than 25. Okay? So this gets rounded to 24. So what we actually do to find the number of neutrons is we subtract our rounded atomic mass. Okay, we've got our rounded atomic mass, and we actually subtract our atomic number, our number of protons. Because the nucleus is made up of both protons and neutrons. So if we take the protons away, whatever we're left with is your number of neutrons. So in this case, 24 minus 12 gives us 12. This is a nice and neat one. We've got 12 protons, 12 electrons, and 12 neutrons. But that's not always going to be the case. You will always have the same number of protons as you do electrons. You may have the same number of neutrons, or you may have more neutrons. You will never have less.